Hello everyone, welcome to my channel on data analytics. I am your host Professor Raghe Uday Kiran. In this video, we learn about data frames and how to transform them into various database forms such as transactional databases and temporal databases. This video covers the following topics. First, we discuss about data frames. Next, we discuss the common formats in which we can store the real world data into a data frame. Next, we discuss the transformations that can be performed on a data frame. Later, we discuss about DF to DB subpackage that is available in the PAMI library. This package purpose is to convert the user provided data frame into a database. Next, we discuss the syntax through which a user can convert a data frame into a database using PAMI library. Finally, we provide a small demo showing the process to convert a data frame into a transactional database. Now, coming to the data frames. A data frame is basically a two-dimensional data structure containing rows and columns. An element in a data frame is called a cell. A column in a data frame represents a series. The entire two-dimensional structure represents a data frame. For data frame, there will be a special structure called index which stores the row information. So, the basic data structure simply represents a two-dimensional array, or we can say M cross N matrix. If you want to find a best analogy to represent a data frame, then it is equivalent to the concept of table in a relational database. Because if you look at a table using SQL, we can do join on a table. Also, we can perform operations such as extract, transform, and load. Now we look at the formats in which we can store data in a data frame. Basically, there are two formats in which we can store data. If you are familiar with information retrieval and extraction, then you may have already come up and familiar with the topic such as dense format of storing the data and a sparse format of storing the data. So we now look at these two types of formats. Dense format is a traditional structure. Most of the real world applications store their data as a dense format. In this format, rows represent transactions and columns represent items or objects. The value 1 in a particular column represents the occurrence of an item generally. Similarly, the value 0 represents the non-occurrence of an item. So this is how we store it. The problem with this dense format is assume that your data set is sparse. It means many cells in your data frame are going to be having zero value. In that case, storing data in a dense format is a computationally expensive process. So it is not advisable to store sparse data in a dense format. To store data in a sparse format, what we do is we convert the dense data frame into a sparse format containing m rows and 3 columns. So this is how the structure gets changed. In sparse data frame, multiple rows represent a single transaction. For example, you can see in this figure that the first three transactions whose TID is 1 actually represent a single transaction. Similarly, in the sparse format, columns do not represent items. The first column in the sparse data frame represents the transaction identifier. The second column represents an item. The third column represents a value. So this is how we can store the real world data, especially the sparse data, in a sparse formatted data frame. Now let us look at the transformations that we can do or perform on a data frame to create a database. So let us first start with a data frame which is storing data in a dense format. If we have the data frame in a dense format, what we can do is we can simply call the algorithm dense format data frame that is available in the PAMI library. And once you use this algorithm using different functions, you can convert a dense data frame into different forms of databases. Similarly, if you have a sparse formatted data frame, you can input that data frame to sparse format data frame. The output is going to be stored in any database format depending upon the function you are going to call. Now let us see about our library df to db. df to db stands for data frame to database. This library you can find it in the extras subpackage of the PAMI library. This library contains two programs. One program is dense format dataframe.py and the another program is sparse format dataframe.py. Each of these programs have several functions which take the user provided data frame and convert it into a format that is required by the user. So let us see the syntax on how do we convert a data frame into a database using df to db subpackage. The syntax is quite simple. So first we have to import the algorithm, say from PAMI extras df to db import. If your data frame is representing a dense format, then please use the function dense format data frame. Or if your data is stored in sparse format data frame, then use the corresponding algorithm. Once you import the algorithm, initialize the algorithm by passing the data frame. Once you initialize the algorithm, please call the necessary function, but means the format in which you want to create the database, use that function. For example, if I want to create a transactional database, then I simply say convert to transactional database and then I will pass some input parameters. Okay, each function has different input parameters. Now let us look at a small demo on how to convert a data frame into a database. For demo purposes, we will be using a data frame that is storing the data in a dense format and then converting it into a transactional database. We use Google Colab for demonstration purposes. First, we download the air pollution data using Widget. Once we download the air pollution data, what we do is using the pandas library, we read the air pollution data. When we print the air pollution data, we can observe that in this data frame, data set, we have the first column as timestamp where we can see the date and hour. Next, each column later on in this data set represents the location of the sensor, and cell in this data frame represents the PM 2.5 value recorded by a sensor at that point of time. If we check various sensors, we can see that some sensors have location information while some sensors do not have location information. Since we do not have location information, what we are going to do is, first and foremost, we remove the timestamp information from the data set, because since we are going to create a transactional database, timestamp information is not needed. So after removing the timestamp, what we are trying to do is we are trying to identify the columns that do not have point information. After correcting those column information, we are simply dropping those columns from the data frame. So this is the resultant data frame. In this data frame, some columns have NaN values. So what we are going to do is, we are going to fill the NaN values with 0 in the data frame. You can see the NaN values were replaced with 0. After replacing the values, we got the dense formatted data frame. Now, to convert this data frame into a transactional database, what we do is we first install the latest version of PAMI library. After installing the latest version, what we are going to do is we are going to call the package PAMI.extras data frame to database. From this subpackage, we will import the program dense format data frame as an algorithm. Once we import the algorithm, we simply pass the data frame to this algorithm. Later, we can convert the data frame into any format. For instance, we are converting the dense data frame into a transactional database using the input parameters. For example, I am specifying the file name in which the transactional database has to be stored, followed by what is the condition I have to apply and the threshold value. So what this function will do is, in the data frame, any column that has value greater than or equivalent to 35 will be considered as 1 and a transactional database will be created. If we print the transactional database, you can see as shown below. Each row represents the location of sensors where harmful levels of PM 2.5 were observed. Each item or each sensor is separated one from one another in a column, in a row, with a separator which is tab in this case. So this way you can create a transactional database. After creating the transactional database, we can study the statistics of the generated data set and use appropriate hyperparameters such as minimum support and so on to discover interesting patterns hidden in this data. Thank you very much for listening to our video. If you like our work, please press the like button, share it with your friends, and subscribe to our channel